Here at IBM Build Labs, we've created some example Kubernetes operators to help our business partners. So let's take a look. Operators help package and manage Kubernetes enterprise applications, which can be shared via marketplaces such as OpenShift's Operator Hub. Let's create the Kubernetes resource that represents a database cluster. This is a custom extension to Kubernetes defined by our operator. Once the operator is alerted to this custom resource, it takes care of creating all the required Kubernetes resources on OpenShift to install our simple database cluster. Even better, the operator also has capabilities to automate common day 2 operations, which can be expensive and error-prone for humans. Let's take a close look at an automated backup scenario. First, we're creating another custom resource to define our backup strategy. The resource defines the connection details for the backup repository, which in this case is Cloud Object Storage on IBM Cloud, and the definition of either an immediate backup or a regular backup to be executed on a schedule. The operator has responded to the database backup resource we just created, and it created a Kubernetes cron job to launch a pod which queries the database and backs up the data to Cloud Object Storage. We can even head over to the Cloud Object Storage now to verify that a storage bucket was created and download its contents. Another example shows how our sample operators can scale up an application automatically based on information that's tracked in a monitoring system. To demonstrate this use case, we have a second operator which responds to another custom resource we called application, and it deploys the resources for a front-end web application. Notice that currently there's just a single web application pod. The web app has a single /hello endpoint which renders a greeting using names that have been queried from our simple database. So let's first check a metric from the web application in the Prometheus monitoring dashboard. It shows that the web app's endpoint has been triggered 7 times. Our application operator also created a cron job which runs on a schedule to implement the scaling decision logic. This approach gives us complete flexibility to make a scaling decision based on any number of factors, not just metrics associated with the web app pod, but potentially other related systems like the database. The scaler pod has queried Prometheus, and based on the number of times the /hello endpoint has been invoked, it's decided that the web app needs to be scaled up. It does this indirectly by updating the custom resource which defines this application, meaning that the application operator will spring into life to increase the number of pods in the relevant deployment. I hope this was a useful demonstration of Kubernetes operators. If you like, you can visit our repo on GitHub to explore these examples in more detail.